Yes, sir.
Below the topic calorimetry, you will have to write a statement. The statement is, if two substances which are isolated from the surrounding, if two substances which are isolated from the surrounding are kept in thermal contact, the heat gained by one substance the heat gained by one substance is equal to the heat lost by the other. Heat gained by one substance is equal to the heat lost by the other. Is that statement clear to you? That is, if we are having two substances, let's imagine that I'm having two substances in my hand. They both are at different temperature and they are isolated from the external environment. Therefore, there is no heat exchange between the surrounding and these two systems. And if they are kept in thermal contact, what happens? The substance which is at a higher temperature will lose heat, and substance which is at a lower temperature will gain heat, isn't it? Isn't it? Isn't it?
Yes.
Yes. Therefore, the heat lost by one substance should be exactly equal to the heat gained by the other substance. That's what calorimetry is saying. Okay. Did I speak about the specific heat capacity, latent heat capacity, latent heat of fusion, latent heat of vaporization and all? Have I spoken about the specific heat capacity, latent heat capacity, latent heat of fusion, latent heat of vaporization? I'm not sure. Have I spoken about all these things?
No, sir.
No.
Sir, we have discussed specific heat capacity.
In a rough manner, isn't it? Just the definition of that.
Yes.
Yes. Therefore, if we are speaking about that specific heat capacity, now a little bit more detail, that is, what is specific heat capacity? Now we know the definition of specific heat capacity. What was specific heat capacity? It was the amount of heat required to raise the temperature of unit mass of substance through 1 degree Celsius or 1 Kelvin. Isn't it? Isn't it? Specific heat capacity is the amount of heat required to raise the temperature of unit mass of substance through 1 degree Celsius or 1 Kelvin. Am I correct? Have I spoken about that in our previous class and all? Yes or no?
We have discussed
I didn't understand what you just said now.
slightly. We just discussed.
Yeah, we have discussed it. You just write the heading specific heat capacity. Specific heat capacity, and we may have to write that definition. It is the amount of heat required to raise the temperature of unit mass of substance through 1 degree Celsius or 1 Kelvin. Okay, 1 degree Celsius or 1 Kelvin. Then for speaking about the equation for specific heat capacity, let me just imagine that an m mass of substance. Please wait, students. My screen has been changed to a black color. We'll have to wait for some time. Are you able to hear me?
Sorry, video is stuck.
Yeah.
Screen is
There's a
black.
black screen. Black screen.
Showing that black screen. Fine. Now my screen has been reappeared. What's about your situation?
Yes. Okay, sir.
Yeah. Therefore, yeah. Then let's just speak about that. That is, let's have a substance. We are having a substance which is of mass m gram. The substance is of mass m gram. And what happens is we are just supplying a q amount of heat to this substance. Q amount of heat to the substance, and there's an increase in temperature of delta T. Let's imagine that we are having an m gram of substance. We are supplying a Q amount of heat to the substance, thereby the substance temperature is increased to an amount delta T. Then the connection between specific heat capacity, mass and change in temperature is Q is equal to C m delta T. This is the connection between specific heat capacity, mass and temperature. This is our connection between specific heat capacity, mass and temperature. Okay, then what's actually specific heat capacity? The term C is the specific heat capacity. In this equation, what's Q? Can you say what is Q in this equation? What is Q in this equation? Heat supplied, isn't it? C is the specific capacity, M is the mass of substance, and delta T is the increase in temperature or change in temperature. Therefore, Q is equal to Cm delta T. It is the relation between heat and specific capacity, where C is the specific capacity. And if we are representing the specific capacity in a particular unit, that is, the value of specific capacity is 1 if the unit is calorie gram raised to minus 1, Kelvin raised to minus 1, or Celsius raised to minus 1. If it is Celsius raised to minus 1 or Kelvin raised to minus 1, now the value of specific capacity is 1. Okay. Therefore, in different units, you will have different values. But let me just say in calorie gram raised to minus 1, Kelvin raised to minus 1, the value of specific capacity, let's say it is what? It is 1. Okay. Since it is delta T, the change in temperature in Kelvin and change in temperature in Celsius both are same, isn't it? Isn't it? ഒരു 2 degree rise in temperature എന്ന് പറയുന്നത് 2 Kelvin rise in temperature തന്നെയല്ലേ? ആണോ? അല്ലേ? I'm not saying 2 degrees equal to 2 Kelvin, but a 2 degree rise in temperature in Celsius is it's actually equal to 2 degree or 2 Kelvin rise in temperature, isn't it?
Yes, sir.
Yes. Therefore, let's just say it like this. The formula for specific capacity is Q is equal to Cm delta T, where C is the specific capacity, and the value of specific capacity in calorie gram raised to minus 1, Kelvin raised to minus 1, or Celsius raised to minus 1, it is 1. Okay. Then next, have I spoken about the latent heat capacity? Latent heat capacity. Yes or no?
No, sir.
Therefore, In order to speak about the latent heat capacity, let me just imagine that we are having a vessel and we are having inside this vessel ice, and let's say the ice is now at a temperature of minus 10 degrees Celsius. Ice is now at a temperature of minus 10 degrees Celsius. Then if I am supplying some heat over to this ice, what will happen?
Melt.
Yes, that is from minus 10 degrees Celsius, the temperature will change to 0 degrees Celsius. That is minus 10 will change to minus 5, then it will change to minus 2. Finally, it will come to 0 degrees Celsius, isn't it? Then from that 0 degrees Celsius at that particular instant, if you are looking at the transition, now it will be ice which is at 0 degrees Celsius. It could be ice at 0 degrees Celsius. And from this situation, if I am just supplying heat, the heat supplied over to the ice at 0 degrees Celsius, it's not causing any change in temperature. 0 degrees Celsius ഉള്ള ഐസിന് നമ്മൾ സപ്ലൈ ചെയ്ത ഹീറ്റ് അതിന്റെ ചേഞ്ച് ഇൻ ടെമ്പറേച്ചറിനല്ല കാരണമാവുക. ഹീറ്റ് അത് വലിച്ചെടുക്കും. It will absorb heat and the 0 degrees Celsius ice will convert into 0 degrees Celsius water. Am I correct? Water ആയിട്ട് convert ചെയ്യില്ലേ?
Yes, sir.
Yes, that is, if the ice at 0 degrees Celsius is absorbing heat, that heat absorbed is not causing an increase in temperature, it is causing a change in state. Change in state. Therefore, let's imagine the situation like this. That is, if we are having an m gram of substance, if we are having an m gram of ice and we are supplying a q amount of heat to the m gram of ice so that it is converting into 0 degrees Celsius water. M gram of ice ileki q amount of heat കൊടുത്തപ്പം ആ m gram of ice m gram of water ആയി മാറി. m gram of water ആയി മാറി. അങ്ങനെയാണെങ്കിൽ ഇവിടെ വലിച്ചെടുത്ത ഹീറ്റ് ടെമ്പറേച്ചർ കൂടാനാണോ സ്റ്റേറ്റ് മാറാനാണോ കാരണമായത്? The heat that is absorbed over here, is it causing a change in temperature or change in state?
Change in state.
It is
Change in state.
change in state. It's actually melting. അങ്ങനെയാണെങ്കിൽ ഇവിടെ നടക്കുന്നത് എന്താ പറഞ്ഞാല് ഫ്യൂഷൻ ആണ്. ഫ്യൂഷൻ. ഐസ് വാട്ടർ ആയി മാറാൻ. അങ്ങനെയാണെങ്കിൽ m gram of ഐസ് വാട്ടർ ആയി മാറാൻ വേണ്ടിയിട്ട് q amount of heat വേണം. യൂണിറ്റ് മാസ് ഓഫ് ഐസ് വാട്ടർ ആയി മാറാൻ വേണ്ടിയിട്ട് വേണ്ട റിക്വയർഡ് ഹീറ്റിനെയാണ് ലാറ്റന്റ് ഹീറ്റ് എന്ന് വിളിക്കുക. അതായത് സ്പെസിഫിക് ഹീറ്റ് എന്ന് പറയുന്നത് ടെമ്പറേച്ചർ കൂടാൻ ആവശ്യമായിട്ടുള്ള ഹീറ്റ് ആണെങ്കിൽ, സ്പെസിഫിക് ഹീറ്റ് എന്ന് പറയുന്നത് ടെമ്പറേച്ചർ കൂടാൻ ആവശ്യമായിട്ടുള്ള ഹീറ്റ് ആണെങ്കിൽ, ലാറ്റന്റ് ഹീറ്റ് എന്ന് പറയുന്നത് സ്റ്റേറ്റ് മാറാൻ ആവശ്യമായിട്ടുള്ള ഹീറ്റ് ആണ്. സ്പെസിഫിക് ഹീറ്റ് എന്ന് പറയുന്നത് ടെമ്പറേച്ചർ കൂടാൻ എന്ന് പറയുമ്പം യൂണിറ്റ് ഇൻക്രീസ് ഇൻ ടെമ്പറേച്ചർ ഇൻ യൂണിറ്റ് മാസ് ഓഫ് സബ്സ്റ്റൻസ്. ഒരു യൂണിറ്റ് മാസ് ഓഫ് സബ്സ്റ്റൻസിന് യൂണിറ്റ് ഇൻക്രീസ് ഇൻ ടെമ്പറേച്ചർ ഉണ്ടാവാൻ വേണ്ടിയിട്ടാണ് സ്പെസിഫിക് കപ്പാസിറ്റി വേണ്ടെങ്കിൽ, ലാറ്റന്റ് ഹീറ്റ് കപ്പാസിറ്റി എന്ന് പറയുന്നത് യൂണിറ്റ് മാസ് ഓഫ് സബ്സ്റ്റൻസ് ഒരു സ്റ്റേറ്റിൽ നിന്ന് വേറൊരു സ്റ്റേറ്റിലേക്ക് കൺവേർട്ട് ചെയ്യാം. Therefore, now in this situation we are speaking about latent heat of fusion. What are we speaking about? Latent heat of fusion. Then what is latent heat of fusion? It is the amount of heat required for unit mass of substance to convert from solid state to liquid state. What is latent heat of fusion? It is the amount of heat required for ഏതെങ്കിലും മാസ് ആണോ? അല്ല, യൂണിറ്റ് മാസ് ഓഫ് സബ്സ്റ്റൻസ് to convert from solid state to liquid state. Are you getting my point? Latent
Yes, sir.
heat of fusion is the amount of heat required for unit mass of substance to convert from solid state to liquid state. Okay. Therefore, let's just formulate an equation for latent heat. Let's just formulate an equation for latent heat. In order to formulate an equation for latent heat, what we have to say is, we have to say, let's say Q amount of heat is required to change M mass of ice to M mass of water. Then latent heat of fusion will have a relation that is Q is equal to M into latent heat of fusion. This is the relation that we have to remember for latent heat of fusion. What's the relation that we have to remember for latent heat of fusion? Q is equal to M into latent heat of fusion. What's Q? It is the heat required. What is M? It is the mass of the substance, isn't it? Then what is LF?
Latent heat of fusion.
Latent heat of fusion. Then what we can say over here is, if the mass is in gram and the heat is in calorie, if the mass is in gram and the heat is in calorie, I could say latent heat of fusion, it's, you have to remember, it is 80 calorie gram raised to minus 1. This is the latent heat of fusion of water in calorie gram raised to minus 1. Are you clear with this? Are you clear with this? Latent heat of fusion.
Yes, sir.
In calorie gram raised to minus 1. In other units and all, we'll have other units. Now we are dealing with this unit. Okay. Is that clear?
Yes, sir.
Then if we are just heating this water again, from the 0 degrees Celsius water, there will be further on, if we are heating it, if we are supplying heat over to it, the water will become from 0 degrees Celsius water, it will rise its temperature, it will become 50 degrees Celsius water, and it will become 60 degrees Celsius water. Finally, it will become 100 degrees Celsius of water. Am I correct? Am I correct? Finally, there is a situation where water will become 100 degrees Celsius, isn't it? Isn't it?
Yes,
Then
sir.
what will happen if we are further heating it? ഇവിടെ ഒന്നും നമ്മൾ നിർത്തിയില്ല, ഇവിടെ നമ്മൾ പരിപാടി നിർത്തുന്നൊന്നുമില്ല, നമ്മൾ പിന്നെയും if we are heating it further from 100 degrees Celsius water, the next transition, it won't be an increase in temperature, but it will be a change in state. It will be a change in state. That means 100 degrees Celsius water, the next transition will be, it will convert into 100 degrees Celsius of steam. Am I correct? This,
Yes.
some heat is required to transform M mass of water at 100 degrees Celsius to M mass of steam at 100 degrees Celsius. 100 degrees Celsius M mass of water നമ്മൾ heat കൊടുക്കുകയാണ്, എന്തായി മാറും? 100 degrees Celsius M mass of steam ആയി മാറും. മാറില്ലേ? മാറോ? മാറും അല്ലേ? Therefore, in this situation, there is a state change. There is a state change from liquid to gas. There is a state change from liquid to gas. Am I correct? അതിനെ നമ്മൾ എന്താ വിളിക്കുക? ഫ്യൂഷൻ എന്നാണോ വേപ്പറൈസേഷൻ എന്നാണോ?
Vaporization.
We'll call it as vaporization. Vaporization. Therefore, we will have to speak about a latent heat over here that is called as latent heat of vaporization. What is latent heat of vaporization? Latent heat എന്ന് പറയുന്നത് hidden heat എന്നാണ് അതിന്റെ വേറൊരു മീനിങ്. Hidden heat എന്ന് പറയുന്നതിന്റെ അർത്ഥം എന്താണെന്നാല് ടെമ്പറേച്ചർ റൈസ് ചെയ്യാനുള്ള ഹീറ്റ് അല്ല, സ്റ്റേറ്റ് മാറാനുള്ള ഹീറ്റ് നമുക്ക് അവിടെ ഹിഡൻ ആയി കിടക്കുന്ന ഒരു ഹീറ്റ്. Therefore, what is latent heat of vaporization? We will have to say latent heat of vaporization is the amount of heat required for unit mass of substance to convert from liquid state to gaseous state. What is latent heat of vaporization? It is the amount of heat required to change unit mass of substance from liquid state to vapor state, like gaseous state. Am I clear to you? Latent heat of vaporization is the amount of heat required to change the state of unit mass of substance from liquid state to gaseous state. Is that clear to you? Is that clear to you?
Yes, sir.
Then the equation that we have to remember in terms of latent heat of vaporization is Q is equal to M into latent heat of vaporization. The equation that we have to remember for latent heat of vaporization is Q is equal to M into latent heat of vaporization, where you already know what is Q. What's Q? What is
Heat
Q?
supplied.
Heat supplied. And what is LV?
Latent heat of
Latent heat of
vaporization.
It is latent heat of vaporization. It is the latent heat of vaporization, and M is mass. Then there is a constant value that you have to remember in the case of latent heat of vaporization. It is 540. And this is also in the unit calorie gram raised to minus 1. In calorie gram raised to minus 1, the latent heat of vaporization is, let's say, 540. Clear? Therefore, there is two types of latent heat, that is latent heat of fusion and latent heat of vaporization. Fusion is converting from solid state to liquid state, that is ice to water. This is latent heat for water. Okay, for different liquids we are having different values. This 80, 541, they are regarding water. Okay, is that clear to you? That's regarding water. Then next we have to speak about the problems regarding this. What did I say about calorimetry? What did I say about calorimetry? Heat gained by a substance is equal to heat lost by another substance. Am I correct?
Yes, sir.
If they are perfectly insulated or if isolated, that means if there is no involvement of an external environment, then heat gained by a substance is exactly equal to heat lost by another substance. That's what law of calorimetry is saying. That is actually law of conservation of energy itself. Energy can neither be created nor be destroyed. I know. Therefore, let's do some problems regarding this. You have to understand how to perform problems regarding calorimetry. Therefore, in order to say about the problems regarding calorimetry, you just take down a problem. That is 10 gram of water. Take down a problem. 10 gram of water at 10 degrees Celsius is mixed with 20 gram of water. 10 gram of water at 10 degrees Celsius is mixed with 20 gram of water at 20 degrees Celsius. And it is again mixed with 30 gram of water at 30 degrees Celsius. And it is again mixed with 30 gram of water at 30 degrees Celsius. What is the final temperature of the mixture? What is the final temperature of the mixture? Is that question clear to you? What's the final temperature of the mixture? Is that question clear to you? We are having 3 vessels which consist of water, isn't it? We are having 3 vessels which consist of water. The first vessel is consisting of how much gram of water?
10 gram.
We are having our first vessel. It consists of 10 gram of water which is at 10 degrees Celsius. Am I
10
correct?
degrees.
The second vessel is consisting of 20 gram of water, which is at 20 degrees Celsius. And the third vessel is consisting of what? 30 gram of
30.
water, which is at 30 degrees Celsius. They are mixed together. That means we are mixing that whole water over here. Therefore, what's the total amount of water in this big tank?
60.
60.
60 gram. And it will settle down at a temperature of T degrees Celsius. That's what we have asked to find out. Okay, that's what we are asked to find out. Clear?
Yes, sir.
Then what calorimetry is saying is the heat gained by a substance is equal to heat lost by a substance. That means if they are mixing means this 10 gram of water which is at a lower temperature will gain some heat. The 30 gram which is at 30 degrees Celsius, it is at the higher temperature, it will lose some heat and they'll settle down at a common temperature of T. Okay. In order to solve these types of problems, what we have to remember is we have to remember an equation. Sigma MC delta T is equal to 0 or sigma CM delta T is equal to 0. Anyway, have you learned that Q is equal to CM delta T or MC delta T?
Yes, sir.
Heat gained is equal to heat lost means sigma net heat in this will be 0. Heat gained and heat lost in the sum and the 0.
Yes, sir.
Heat gained is equal to heat lost means sigma Q will be equal to 0 or sigma CM delta T will be equal to 0. I'll show you how to write the equation. How to write the equation എന്ന് പറഞ്ഞിട്ടുണ്ടെങ്കിൽ ഈ 10 degree Celsius ഉള്ള 10 gram of water എന്തായി മാറിയിട്ടുണ്ടാവും? ഒരു T degree Celsius ഉള്ള water ആയി മാറിയിട്ടുണ്ടാവും അല്ലേ? ആണോ? ഇതെന്തായാലും ഇവിടെ ഉണ്ട്. അത് T degree Celsius ഉള്ള water ആയിട്ടുണ്ടാവും. 20 degree Celsius ഉള്ള 20 gram of water ഇവിടെ എത്തുമ്പോഴേക്കും എന്താവും? T degree Celsius ഉള്ള water ആയിട്ടുണ്ടാവും. 30 gram ഉള്ള 30 gram of water ഇവിടെ തന്നെ ഉണ്ട്. അതും എന്ത് ചെയ്യുന്നുണ്ട്? It is converting back into T degree Celsius of water. Am I correct? Am I correct?
Yes.
Yes. Then if we are starting this MC delta T, what's the value of C? We know the value of C in this calorie gram raised to -1, Celsius raised to -1 or Kelvin raised to -1. The value is C is equal to 1, isn't it? Isn't it? Therefore,
Yes, sir.
M. In the first vessel, we have to write 10 into 1 into, that is M into C into. Delta T means what's the initial temperature? What's the initial temperature? 10. What's the final temperature? Final temperature is T. Final temperature of this 10 gram of substance is T. Therefore, let me write like this. നിങ്ങൾക്കത് T minus 10 എഴുതിയാലും കുഴപ്പമില്ല. T minus 10 എഴുതാണ് എല്ലാ സ്ഥലത്തും T minus 10 എഴുതണേ. That's the only difference. Then plus അടുത്തത് 20 ഗ്രാമിന്റെ MC ഡെൽറ്റ ടി എഴുതുകയാണെങ്കിൽ 20 ഗ്രാമിന്റെ M എത്രയാ? 20. 20 ഗ്രാമിന്റെ C എത്രയാ? It's 1 into 20 degree Celsius T degree Celsius ആയിട്ട് സെറ്റിൽ ഡൗൺ ചെയ്യുന്നുണ്ട്. അപ്പം let me write 20 minus T. Can I write like this?
Yes.
Yes, sir.
Plus next one. 30 degree Celsius ഉള്ള 30 gram of water ഉണ്ട്. അപ്പൊ 30 gram of water ആയതുകൊണ്ട് 30 into 30 gram ആയതുകൊണ്ട് കേട്ടോ M ന് പകരം 30 into C ക്ക് പകരം 1 into delta T. Delta T is what? 30 minus T. That is equal to 0. Can you just solve this for me? If you are solving this, what we can see is here we are having a 10. Here we are having a 20 and here we are having a 30, and we could cancel the zeros from that. Then it will become, can I write 10 minus t plus 2 into 20, that is 40 minus 2t plus 3 into 30, 3 3s are 90 minus 3t is equal to 0, because I've just cancelled that zeros. And what's the final answer? Can you just say the final answer?
20.
Is it 20? What's the value of t? So I'm having
20.
only the question with me. I'm not having the clear-cut answer. Can you just give me the answer? This is the
23.
important part in heat and thermodynamics.
23.3.
Is it 23.3?
Yes.
23.3 degrees Celsius, isn't it? I'm not sure. I'm just believing you. Okay. Did you understand this method of solving it?
Yes, sir.
Yes, sir.
Shall we have another question? Let's just have one
Yes.
more question which is similar to this. You write the next question. Can I just say the next question? All of you just
Yes,
say okay or not okay. If this question is clear to you, you just have to type okay. If it's not clear to you, type not okay. If you're typing not okay, it's your responsibility to unmute your audio and ask where you are not understanding it. Then take down the next question. The next question is m comma 3m m comma 3m gram of water, m comma 3m gram of water at 40 degrees Celsius, comma 50 degrees Celsius, comma and 60 degrees Celsius. At 40 degrees Celsius, 50 degrees Celsius and 60 degrees Celsius are brought in thermal contact. Find the final temperature. Find the final temperature. Now, what's the situation that we are in? Here also we are having 3 vessels, which is consisting of, first vessel is consisting of m gram of water, which is at how much degrees Celsius?
40.
40 degrees Celsius. Second vessel is also consisting of m gram of water, which is at
50.
degrees Celsius. The third vessel is consisting of m, it's not m gram,
3m.
3m
3m.
water, which is at
60 degrees Celsius.
and if they are mixed together, the total mass will be 5m, isn't it? 5m mass of water will be settling down at T degrees Celsius. You have to understand, we have to find out the final temperature. What's the formula that we have to use over here? Sigma
M delta.
Cm delta T or MC delta T, isn't it? Then we'll start with the first one, the sigma. If I am writing C first, I could write, I'm not using that sigma. I'm writing C first, that is 1 into masses M into delta T means, what should I write? 40 minus
40 minus T.
T plus 1 into masses M into 50 minus T plus let me just write it in the correct way itself. 1 into, it is 1 into 3m into what? 60 minus t, that should be equal to 0, isn't it? Then from this we could cancel this m. Can I?
Yes, sir.
Yes. Then we could just simplify it. You just simplify it and give me a final answer. What's t is equal to?
54.
T4.
Is it 54 degrees Celsius?
Yes.
Yes. Therefore, the t value is 54 degrees Celsius. Okay. Is that clear to you? Is this problem clear to you?
Yes, sir.
Yes. Then let me just say another problem. We'll discuss that problem in our next video. That's you have to take a break. I'll just give the question. You write the question. 10 gram of ice, 10 gram of ice at 0 degrees Celsius, 10 gram of ice at 0 degrees Celsius is mixed with 20 gram of water at 30 degrees Celsius. 20 gram of water at 30 degrees Celsius. How much gram of ice is left behind? How much gram of ice is left behind? How much gram of ice is left behind? That's our question. Okay. Did you understand the question? We'll have a break, and after the break, we'll find a solution for this. You can take a 10 minutes break.